I wouldn't be in teaching if I didn't want you all to succeed. 'Cause I don't really care. I just want to golf.
Could you just stop working? Or
Oh, easily.
And just golf?
Oh, I could just stop, but I mean that would be boring.
Really?
Yeah.
What would you do? Golf?
Yeah, I mean, but then your life isn't fulfilling, right? You're just sitting there, and I mean, don't you get a reward out of like helping other people? Well, I mean, seriously. So I mean, let's turn it into,
Okay, you're right. If money was not an object, and then I would still do stuff. You're right.
Well, so I mean, let's turn it into a Christian worldview discussion. So let's get points. Let's get points here. So when people go and do mission trips, or go out to an old age home to help people, I mean, they're not getting anything in return. They're when I go with my church on a Saturday morning to do one of these soup kitchens. I mean, I'm not qualified to do the cooking or something like that, but I could pour the milk in cups, right? To give people coffee and go around and give them refills. I mean, is that worth my time in terms of dollars? No, right? But it makes you feel good about yourself because you're helping people that need the help. So I mean, if you always focused on stuff that was all about you, that's like good for a couple of weeks because you're like pampering yourself. That's kind of what a vacation is, right? When you go on vacation, it's like, oh, I'm going to get massages. I'm going to go and, we're going to go on, to the water parks, whatever you're going to do. You say you're just spending money on yourself. That's fine. That's what a vacation is it's all about you for that, right? But the rest of your time, wouldn't you feel kind of empty if everything you did was just about what was fun for you? At first, it might seem rewarding, but I mean, so I guess I'm telling you this from experience because, I was very successful financially very young in my life and played that game of, oh, why do I need to work, blah, blah, blah. Yeah, money's not very important. Seems more important than it is, but it's not, doesn't.
Money's pretty important, but once you have
but that's not true. It really isn't true because what ends up happening is you end up thinking you're better than people because your bank account has a higher number in it.
Sure.
And then your problems become bigger problems because you buy yachts and stuff like that. If you haven't heard that story, have me tell you outside of class sometime my $500,000 yacht story sometime. But the
I could have a $500,000 yacht story.
But the punchline is it was probably one of the least rewarding portions of my life. It's your life becomes very empty when you don't have any carrots to chase.
So you feel more fulfilled now than when you were making just disgusting things.
Hundreds of times more.
Wow.
Yeah.
Well, I think I'm going to try the whole make a ton of money thing first and maybe get to that.
Oh, no, fair enough. I mean, that's the carrot to chase, but don't chase the dollar. Chase the passion for the knowledge or passion of what you're doing and help other people. And it all comes back to kind of the same argument like tithing, right? I mean, so if you go to church, we've all heard the tithing story, right? It's like, oh, give 10%. Is that before or after taxes and stuff like that? And it's hard for human beings to do that, isn't it? I mean, 10%, that's a lot, right? My brother once put it to me, and you got to keep in mind, I was born Jewish. I come from a Jewish family. Okay, so it becomes a very interesting argument because, all those Jewish stereotypes, true. Okay. My dad's one of 7 brothers, all doctors and lawyers. Every one of them. Okay. Every one of them. Okay. All of them are filthy rich, blah, blah, blah. So, I grew up with these lessons. Well, my brother is Christian as well. And we both converted in our teens. And so he once talked to me about tithing. And the way he put it is, it's not like you're giving 10%, it's God's letting you keep 90. Still doesn't make it easy. Okay, because we're greedy, right? Everything's about us. What's in it for me? Blah, blah, blah. It's like, oh, well, I could spend that money on something else. But yeah, I mean, if you don't have kind of a humanitarian-based carrot to chase, and everything's just for the dollar, that gets old real quick. Trust me. Chase your dollar. I mean, I mean, you want to have an amount that allows you to live a lifestyle that you want to live, right? I mean, money is necessary to a point. But gobs of money versus enough money, the difference isn't as much as you think in terms of happiness.
No, I don't.
Because a lot of times money gives you the excuse not to treat other people the way you'd want to be treated.
I don't disagree with you on any of this. I don't see myself.
I mean, would anybody in their right mind pay you an hourly wage that I'm paying you? Yeah, so. It's because I feel sorry for you, and in fact, I'm better than you are. So by paying you,
all along. Just reaffirm
yeah, treat other people the way you wish you were treated at that age, and it will pay dividends. Trust me. And what'll end up happening? Just you're going to end up stealing my clients away, and so that's fine.
Cool. I've been under the table.
I'll find new clients.
Charging you have that. Have that.
Have at it. I don't care.
I wouldn't do that.
I still don't care. I'll go find new clients. And then I'll get another student involved when they step up and show some, aspirations and development and stuff like that. And then they can steal that client from me too. It's the way the world turns. Because I want to be golfing.
Yeah, I guess that's pretty great mindset to have there.
Well, that's what I'm saying is I'm happier today than I was when I was making millions a year. Way happy. I mean, it's not even close. So hopefully you don't have to find out the hard way. Hopefully you'll take some of my advice for it. But go and do. No, you can make the millions, but do something good with it.
Oh, for sure.
Yeah. Don't use it to buy a yacht that you don't use. Don't use it to buy a mansion that you don't need.
None of that has ever appealed to me. I don't see the extravagant displays of wealth as. I will have the sickest setup inside of my house. I don't need it to be a million.
That is kind of my approach.
Yeah.
So I mean, we have a
your $10,000 Mercedes.
Yeah, we have a nice enough house, but it's too big for two people, right?
Yeah.
We used to have 3 cats, but I have nice things in the house. So that's your pampering. I don't need 30 rooms. I mean, can you imagine how hard that would be for my wife to clean? See, really, we truly just got biblical because in the Bible, a lot of times the women are second-class citizens, right? Yeah. So
Christian worldview. That's 2 this morning. No, this is like a million.
Heavy points, and it's reality. Tell you what, dollars are overrated. What was I talking about? Oh, I guess we're not doing a quiz now. Okay. So, I gotta open a. Here, I want to steal some of this stuff because this is stuff from the other class that I don't want you to see yet.
Are you talking about the master's class?
Yeah. This is fine. All right, but I do want to, let's see, last time we were doing, we had the function for writing a string, right? And we started looking at, I think the bug I left you with at the end of class last time was we were reading in a string? We were looking at the DOS API, right? We did a Google search. We found, though, there was this random 9H thing. I think it was writing a string out, wasn't it? Pretty sure it was writing a string out. Well, let's kind of see where those things come from, okay, and kind of understand how they work. So now when I say API to you, so this is more of a tech term, right? So what does API mean to you? Everybody but Curcio. Go ahead.
It's a way of interacting with a third-party software. It allows you to utilize their software, at least the parts that they want you to be able to utilize. So, like the Twitter API, and it allows you send tweets or gather information on things.
Okay. So, you have these third-party products, a silo, so let's say you want to, a lot of times in tech, they're called silos, right? So they're a private entity that has stuff inside, much of which we don't have access to. So for instance, would any of us expect Amazon to give us access to like their business records and stuff like that? No, that's private business data that they're going to protect, and they're not going to expose that data to us, right? Okay, but are there aspects of Amazon that would make sense for Amazon as a business to expose, right? Like their list of products. I mean, wouldn't it be in Amazon's best interest for web developers and app developers to be able to show a list of Amazon things and drive people to Amazon's site to buy crap from Amazon? Oh yeah, I mean that only helps them, right? So they have to somehow provide a tool to give access to the public information that they want to have, they want to have available to us without giving them access to the private stuff. Okay, you can get our list of products. You can do a sale through Amazon sale processing, but you can't have our tax records. You can't have all these other things. So an API would be a collection of, think of them like functions. A collection of functions that allow you to accomplish the things that a third-party company might want you to accomplish or might want to allow you to accomplish. That makes sense? All right, so when we talk about, an API for Amazon, we think maybe that it's for getting a list of stuff. Another API that I've worked with a bunch is an API called Stripe. And Stripe lets you process credit cards. So you can incorporate that into apps so you can, process credit cards. So most third-party companies today have APIs. When you go to these hackathons, so some of you have come to some of the hackathons with the computer science department that we go to, usually the very first day there's 3 or 4 companies that kind of present their API. Like, hey, we're company XYZ, this is what we do, this is why it's good, blah, blah, blah. And here's the stuff you can do with our API. Right? So a good example of this, and it's actually a company that has become big since I first met them at our I think the very first hackathon we did through Concordia, well, as Concordia, we didn't do it here. We're actually doing our first hackathon, November something?
It's coming out this year.
Yeah, we're actually hosting a hackathon here. There'll be more information coming out, but the date's sometime in November, I think, but whatever. But it's only a half a day one, so not 24 hours. But it's a company called Twilio. Any of you heard of Twilio before? Okay, what does Twilio do? Maybe those of you who haven't been to the hackathons, who know exactly what Twilio does. Okay, and it's actually become more than that now. But yeah, no, they don't. That's Venmo that does payment. So Twilio started off as, hey, I have an app and I want to be able to send people SMS text messages. Well, that's actually a hard thing to do because every company, AT&T, Verizon, they use their own little proprietary way of handling text messages. Well, you don't always know who the phone number you're texting, you don't know who they are. Are they AT&T? Are they Verizon? Are they Sprint? Whatever. So what Twilio does is they're a company that's in the middle that says, we know how to send text messages to all the different providers. You give us a cell phone number, we can text it. That idea. So now when you want to send a text message, you use Twilio's API to send a message out to somebody. Okay, and you get a number from Twilio and stuff like that. But they've grown beyond text messages. Now they can also do voice. So they can they'll make a phone call to somebody, and you can give it the message, and it'll have a robotic voice that's not overly robotic, but you can tell it's not a person. You can have it say stuff. So you can make an app using Twilio that effectively makes crank phone calls. Good. You legitimately could do that. But so the punchline is there's all sorts of third-party companies like this that have services that they want to provide you, that they have a public aspects of their services that they have to give you a way to use, and that's where these APIs come in. All right, so we go back years and years and years and years and years ago for us to the early days of what we would call personal computing. We're not talking about the machines that lived in gymnasiums and stuff. We're kind of talking about the early DOS computers, 8086, 286, 386 DOS computers. And, DOS is an operating system, right? Okay, now what's an operating system? What's the quick 2-sentence description of an operating system? Some of you are in 350 right now, right? Okay, what would you say is an operating system? Go ahead. Okay, I don't think that's unreasonable. Anybody have something want to add to that? I always find it funny that when you're asked a question in a tech class, in your mind you start trying to formulate this really tech-sounding answer, don't you?
this and that and it and us.
But go ahead.
The interface that helps the person control the computer.
Yeah, it's the thing that sits between us and the electricity and the boards and stuff, right? Because we don't want to sit there completing circuits like it's like, okay, well, this is gonna hurt. We don't want to do that. That's not it's dangerous. Okay, I one time changed a light switch. Now you're supposed to turn the power off when you do stuff like that. Yeah, my wife doesn't let me do those things anymore. I hire a guy or a girl. Pretty much everybody knows more about that than me because I got blown across the room.
Wow.
The thing is, it didn't even hurt. Like,
No, it just zaps for a second.
but I was on the other side of the room,
I have a great image of this happening.
Yeah,
and I was this
It's like it
size.
crashed through 3 walls in my head.
Yeah, I was. I mean, I was this size, and I flew across the room. I probably flew back 7, 8 feet. I was in a chair.
Wow.
Yeah, but I was like fine.
Wait, what was this that you were working on?
It was at my house when I used to teach at Western Illinois, and there was an outlet, light switch thing, and we were trying to replace there was something, the switch wasn't working real well, so I was trying to take the, you would think with a PhD you should know you turn the power off. Yeah, no, because I think the guy thing took over. Yeah, it didn't work out so well. So I'm like in there with screwdrivers and stuff, touching electricity. My wife yelled at me.
Before or after you got shot?
After. Well, actually before, she was telling me, asked me if I knew what I was doing. I have lots of videos of that. There's some video on YouTube, I think, of
Really?
me with an RC car. Like it's like one like the gas-powered RC cars that have the real engine and stuff, and I was screwing with that, and I didn't know what I was doing. I was trying to like make it faster and stuff, and this engine almost blew up in my face. Okay, but she's recording, and I'm like twisting stuff, and all of a sudden you hear the motors going. And then I like jump back and I pull the gas line off of it so it shuts off. And she says, "Do you know what you're doing? Because it doesn't seem like it." It's all recorded. But so in any case, I don't know how I got on electricity and shocking myself, but the operating system sits between us and the hardware because we don't want to have to manipulate hardware directly. Okay, so the operating system does a whole lot of crap for us that is make computer work kind of crap. You mentioned it as it's a resource manager, right? So we have things in our computer that we want to manage, and one of the things that we might want to be able to do with some level of convenience is maybe display something on the screen, read something in from the user, among many other things, right? All right, so the operating system has facilities for doing those things. Now, would you say that you have lots of programs on your computer today that allow you to type stuff in and it retrieves that information and does something with it? There are many different pieces of software that were not written by Microsoft, that were written by other people, right? Okay. There are lots of programs that you have that display something to the screen. Also not written by Microsoft, and so they all. That's kind of a main thing, right? They all display stuff, right? Okay, so we have lots of stuff that was not written by the people who wrote the operating system. Well, heck, Microsoft didn't write the operating system. They've added to it, but they didn't write the core. They did for NT, but whatever. So the punchline is that even an operating system is effectively a silo. It's a third-party service that has public interfaces that they want to expose to us so that we can take advantage of it somehow, right? Now, the issue here is who actually talks to the operating system. We want to understand those layers. So when we come in here and we draw our little picture, so this is our computer. And we could pretty easily just say CPU there, right? That's kind of that's the part of the computer that we issue commands to, and then it does the don't electrocute yourself stuff, right? All right, so we have that computer. Sitting on top of that we have an OS. Sitting on top of that, we're going to call it system call API. And we need to color code these guys, right? And then sitting on top of that, we have our application program. All right, so, well, and then on top of that, we have our user. Okay, so there's a lot of layers between us and the hardware. So we got this operating system that provides low-level resource management. That's at the end of the day, I think that's a pretty concise and accurate definition of an operating system. Okay, but that resource management is done for the betterment of us. All right, because he kind of pointed out the more practical maybe definition that the operating system is the thing that sits between us and the computer so that it helps us people do things with the computer, because that's not really our forte to work with connecting wires and dealing with things at zeros and ones, which is why we really don't like assembly. Hopefully we're finding it intriguing or interesting at some level, that working with the CPU at it's the one-to-one level that we're doing in here. But how many of you would want to do this 8 hours a day on a day-to-day basis for any sort of prolonged period of time? I mean, it might be cool for a month or two to say, I basically spend my days talking to the CPU. Yeah, it's my best friend. But after that, you're going to spend a lot of time accomplishing very little, right? I mean, that's the nature of a low-level language. So, as human beings, we love power tools, right? So, this whole system here in the middle is all about providing us with power tools that allow us to take advantage of this guy in the most convenient way. All right, this is why we drive cars. We push the gas pedal and car goes faster. Okay? We're not sitting there, feeding coal into the engine. Like, want to go faster? Just keep shoveling, or whipping the horse or something to make the horse go faster, or go weaving back. You're just on foot and you're whipping yourself. You're just huffing and puffing. You're out of breath. Like, you just a little farther. That's what I have to do every single morning when I go out for my run and I'm going from my bedroom to the fridge in the kitchen. I have to give myself a motivational pep talk halfway there. Could anybody else make a class like this? It's entertaining. If only that wasn't true. But now I do have new Wi-Fi lights, though, that help light my way. The Philips Hue?
Smart? Yeah, those are sick.
They're
like
yes,
$60
sick as in stupid, right?
You don't like those? Sick as in stupid, as in like stupid cool or stupid stupid?
So my wife likes these bulbs. So they just came out with the 2.1 version that can actually show the color green.
Wow, they couldn't do that before?
Nope, not green.
Quite an advancement.
Yeah. So the starter pack is like $200. That's 3 bulbs.
Ouch.
Did you know most houses have more than 3 bulbs? Yeah. I don't. I mean, I have like a 3,500 square foot house. I don't have, so it's a decent sized house, but not
Light
like.
bulbs?
Yeah, more. Yeah. I'm about $500 deep into bulbs right now in this past week, and that's at a discounted price.
Wow. But your house is a rave now, right?
Yeah, I'm not in control of it. It's something with HomeKit, but I ran into an issue yesterday when I went into the kitchen to take my medicine at night, and my wife had already powered down the kitchen, I guess. It literally takes a PhD to get the lights on.
How about changing a light bulb? How many PhDs does it take then?
Well, I mean, what do you do? You're flipping the switch, right? If you walk into a room, and the lights are off, and you want the lights on, what do?
You turn on the
You
lights.
flip the switch.
Those doesn't work that way?
No. See, the power is never off. And there's always power going to the bulb. It's the bulb itself. So we'll connect this to what we're talking about. So, okay. The bulb
Well, doesn't it have?
has an operating system called HomeKit that says, look, the electricity is always there, but we will hold it back. Okay, we will keep the electricity from getting to the bulb. And then the bulb itself has a CPU inside of it. It says, you know what, we're going to turn that electricity into a whole bunch of different colors. But when you want the light off, we'll just keep holding it back. So what happens when I flip the switch in my kitchen? I turn the light off. Power was already on. Okay, bulb just wasn't showing it. So I turned it off. No light. So then I turn it back on. And the light goes into default light mode. And you know what it looked like? It looked just like the 49-cent bulb I had in there before. Okay? Just a white light. Right, so then I took my medicine, and when I was leaving the kitchen, I'm going to bed. So I'm like, oh, you know, by bed I mean going to play video games. All right, so I decide, you know, I'm leaving that part of the house for now, so the light should go off. So how do you turn the light off when you leave a room? You flip the switch. Okay, but no, I flipped the switch. All of a sudden, I just disconnected my wife's smart light. Okay, which she has now set up to come on or off at all sorts of times. Yeah, I woke up this morning, the lights in the whole house were on, just ready to go. 6:30 a.m. on. Yeah. So so then I had to oh well, I can't do that. So I flipped the switch back on. Now I'm back to default light. And I talked to my watch. You know, hey Siri, turn the kitchen light off, which keeps the electricity flowing, but keeps it from getting to the light.
So will your energy bill go up, be substantially higher because it's?
It should be substantially, no, it should be lower because you're not draining the energy. I mean, you know, the power's coming to this part of the switch here. When you flip the switch on, power just goes here. We're just stopping it here. I mean, it's not doing anything extra. Yeah, that makes no sense to me. Those bulbs.
Are they meant to be a whole house thing? I thought they were meant to be for specific, by your TV you put those bulbs so you can do mood lighting for stuff. Or
Oh, those exist too. There's things you can put behind your TV that flash. Yeah, I don't know. Yeah.
Your wife's in charge of the light bulb decisions.
Yeah.
You just have to live with.
I'm in charge of 2 things at my house.
What are those?
Well, 3 things. Massage chair. 5 things. Massage chair, air conditioning, hot tub, boat.
Mr. Gonzalez.
6 things. My wife's in charge of everything else, including the air conditioning sometimes. I very often walk by and I find that the number is set significantly higher than I had set it.
So that must be ghosts in this house because I know you didn't change the.
No, I said, did you touch the air conditioner? She said, yes, I was cold.
Yeah.
And she's wearing 6 layers and wrapped in a blanket.
And you're you should try fat. It works.
Yeah, get an insulator. Who needs that many blankets? She just got this new comforter for our bed. The thing's 14 inches thick.
Do you sleep with that on you as well?
No, I don't. She doesn't even let me sleep in the bed. I'm on the floor next to the bed. She has to spread out. She needs space. Mr. Gonzalez sleeps on my side of the bed. All right, let's get back on topic. So this is the layer of HomeKit where I'm having to talk to my light bulbs so that I don't have to use a switch on the wall. Because as a human being, we can handle 1 switch. Good with that. Okay? But computers, it's a little bit more than 1 switch. We have lots of switches on computers. So I can see these layers existing for that. All right. Well, so you have the OS. Now, are OSs complex things? If I gave you a homework assignment to write an operating system, would you be happy about that? No, I mean, that's hard, right? Operating systems are important. They do a lot of things. I mean, you say they're a resource manager. How many resources do we have in our computers? A lot. We have a lot of resources, right? Even we've just been talking about the CPU in here, and we have all these registers, AX and BX and CX and whatever X, right? We have all this stuff. That's just the start of it. Okay, you have gaming mice and headphones, and now you have VR helmet things that are. I mean, you got all sorts of stuff. Those are all resources. A lot. More than just a switch. So we kind of rely on this dude doing a lot of the heavy lifting for us, okay? Because human beings are innately lazy. We want to take advantage of our, we want to take advantage of our technology, but not at the cost of it actually being work for us. Hasn't it actually been an interesting, dynamic in our society? How much technology has allowed us to do things that we couldn't do before. I mean, even take it to something like a telephone. When I was a kid, our telephone was attached to the phone, which was attached to the wall. So if you wanted to speak on the phone, you had to be within like 3 feet of the phone. Well, now your phone is within 3 feet of you, wherever you go. That's technology, right? That technology has allowed us to do that, and that's cool. We all like it. Right? We like some of the things we can do with this technology. So we like that it's really cool. But we were just talking at lunch today at our meeting. And this was something I learned from a student here at Concordia. This is my 11th year here. So I think it was my second semester here. It was when Dr. Locklear used to do the 491, the senior seminar class. And I sat in on the presentations. And the quote was something, this might have been something Dr. Locklear explained to him, but I was impressed from the student because that's where I first heard it. And it was that technology exaggerates what's in your heart, or amplifies what's in your heart, right? So we were just having a discussion at lunch today about stealing and things like that. So like most of us wouldn't go into Target and steal a DVD. Consequences, right? We don't want to get hauled out by the cops in cuffs because it would be embarrassing. And we don't want to spend the night in jail because we have a nice comfy bed at home. Okay? But you don't have to raise your hand. But many of us have.
What you're about to do. One is stealing. One is copyright infringement.
But fair, whatever.
It's sharing.
Yeah.
I think it's sharing.
Point is that regardless of whether you can argue it's not the same thing, most of us have at least done something on the internet that would be questionable, right? Downloaded a movie that we didn't pay for or something like that.
If you've only done something that's questionable, then you're an angel.
Oh, fine. But so the point is that we tend to not look at those as identical, as the same crime. And it has more to do with the perceived consequences, right? So technology has allowed us to effectively become more evil because we can get away with it.
I would say it's anonymity that allows it.
Fine. And so then the technology has given us the ability to be anonymous and whatever. So you can follow the path whatever way you want to go. But I was impressed when the student said that it amplifies what's in your heart. And isn't it true? I mean, at some point, have you ever been sitting in front of a computer and found that something that you shouldn't have been doing was too easy to do? I mean, even legitimate things, right? Take out the phrase shouldn't have been doing. There are things that we can do with our computers today that were unthinkable to be able to accomplish, period, 30 years ago, 15 years ago, 10 years ago. Even we did our VR demo this, last week. I mean, that's made up stuff, right? What's the next step? You got the Star Trek holodeck thing. It's amazing, right? So, if we fast forward 10, 15, 20 years in the future, people are going to be looking back at these VR helmets and laughing. Like, oh, they used to have to wear something? They had to put something over their eyes. Oh! Like, oh, people used to have eyes? Yeah. Now, as soon as you're born, they pop those out and they have to put the Terminator eyes in. Yeah, the eye eyes. Instant upgrades. All right, so the point here is that this guy is incredibly complex. The more general purpose the operating system, the more complex it's going to be, right? I mean, you have little tiny operating systems that control like toasters or control washing machines and things like that, which important, right? But obviously a washing machine does far fewer things than a general purpose computer. Okay, so as these operating systems become more general purpose, they become more complex. But from our perspective in this course, it's not unfair for us to say that operating systems are complicated. They do complex things that we don't want to have too much to do with. We want to get the benefit of those guys. We want to be able to appreciate all the stuff the operating system is doing for us behind the scenes, but we really don't want to work for it. We want it to be super convenient. That's where we've seen, the graphical user interfaces and stuff come from. But now on top of that, most of us, well, here, let's ask this. How many of you have actually directly used your operating system this week?
I guess you got to define directly use.
Well, what's the operating system? It's not Windows, it's the kernel. So how many of you have directly manipulated or directly worked with the kernel this week? It's possible you could have. Technically we did on Tuesday, but it was a simulated kernel. So, but we don't. What do? We use application programs, right? You launch Word, and you use Word for doing word processing crap, writing the paper you didn't want to write. All right, but that guy's doing all the magic tricks behind the scene, talking to the CPU on your behalf, doing all the stuff that you don't want to do, so that you can just use the tool. Make sense? Okay. Just like when we are mowing the yard, we're not the one manually spinning the blade. There's a motor that's burning gas or whatever that's spinning around and cutting. We just push it. We keep it around. We take it where the grass needs to be cut. All right. So this guy right here has a whole bunch of stuff it's doing for us, but we most of the time interact with that through application programs that somebody else wrote. Right? Microsoft or whoever wrote your video games, that kind of stuff. But now, sometimes we, especially as computer scientists, we're going to write our own software. And sometimes we want that software to be able to talk to the operating system because we might want to do things that the operating system, that utilizes tools that the operating system provides to us. How do we do that? Well, we can either have, a great depth of knowledge of the operating system along with the actual source code for the operating system so that we can take advantage of all the different classes or whatever that make up the OS, augment it with our own new functionality, recompile the entire operating system, reinstall it. And so I assume the last time you guys downloaded a little program off the web, it required you to recompile and reinstall Windows 10? Yeah, it was like a multi-day type process. Any of you ever compiled an operating system before? I'm mostly asking, have any of you done any of the Linux build your own kernel? Like Gen 2 Linux was a long time ago, was a famous thing for that, where so why just install Linux when you can build it yourself? How long do you think it took back there? So forget about what the speed of the machines were. It would be relative to the same as it would probably be today because the operating systems would be bigger. How long do you think it took to compile the Linux kernel?
12 hours.
Yeah, it was like something like that. It was like 8 to 15 hours or something like that. Every time you install an application, you got to rebuild the kernel? No. Now, the good news for us today, especially from a compiler perspective, and this is related to this assembly language stuff, is can you imagine that under the hood, a program like Microsoft Word probably has a lot of assembly language files associated with it? Right? Most of those guys would have been generated by a compiler, like from Visual Studio, compiled your .NET C# code into Microsoft Intermediate Language, which then turned into Intel architecture assembly, right? But at the end of the day, it's 50 files, 50 different assembly files that go into making Microsoft Word. It's probably a lot more than that, but let's just use that as a number. All right, so we have 50 different assembly files. So to actually build the executable, we link all those files together, which builds our .exe. All right, that's Microsoft Word, is the gathering of all these assembly files. So now when we change something in our program and we recompile it, it's only actually recompiling the portion of our program that has changed. And then it's only actually outputting the updated assembly language programs. And then the linker only actually replaces those couple of assembly language, those assembled programs into the executable. So you don't have to rebuild the entire OS. It's a modular application. So these are DLLs, dynamic loadable libraries. Okay, so over the years we've gotten better and better of making things more convenient for us, even at the low-level software level. Now, this operating system has a bunch of things it provides to us. Rather than us directly manipulating the operating system and having to rebuild it every single time, wouldn't it make sense to say that this guy is a static being? It's just there. We don't change it. And it would expose its tools to us, kind of like we're borrowing DOS's garage. All right, so DOS has a garage that has a bunch of tools hanging on the wall, and we can walk in there, and any of those tools that are hanging on the wall, they're saying, hey, look, you're allowed to use those. Some of them might have, some caveats like, hey, are you trained on the chainsaw? If not, you're not allowed to use that. So if you're not the administrator, you can't use that tool or something like that. But most of them are available to you if you want to use them. Then when you write your application program, so that would be us, we can write that program in terms of tools that are provided by the language and the architecture that we're using, as well as system calls that are part of the operating system. Make sense? Those are available to us as part of our programming. Now, realistically, most of us are high-level computer programmers. So we're using languages like C# or Java or Swift or whatever. A high-level language, not assembly. So our high-level language adds more layers. It's like, well, we're not going to have you talk to the DOS API directly. You'll talk to Java's I/O library, which talks to this library, which talks to this library, which ultimately talks to the operating system through the virtual machine. It's even an extra layer with Java. So, punchline is from most of the time, we are not directly interacting with our operating system, but indirectly, we're still using the system calls of our operating system. Now, as assembly language programmers, we don't have access to that high-level language that's implemented all these nice little magic tricks for us. So we're literally walking into DOS's garage and saying, okay, what are the things that I'm allowed to do? And now I have to solve all my problems in terms of those things plus the Intel architecture commands that came with the assembler, right? So we're using the 8086 assembler, which is fairly standardized when you get to some more modern assemblers like MASM and TASM. Sometimes there's a little bit different syntax, but the registers are usually called the same things, and they ultimately all translate into the same magic tricks under the hood. All right, so our tools come from two different garages. One is the DOS garage, which is a relatively small garage that has just the magic tricks that were thought to be exposed by a very early version of DOS. Okay, and then the other garage is the garage that has the magic tricks associated with the 8086 Intel architecture instruction set. So we have to solve all of our problems in terms of the tools that are in those two garages, as well as binary and hex, just our own imagination and working with those kinds of values. That makes sense? Those are the tools in our toolbox, and unfortunately for us as assembly programmers, each one of those tools doesn't do that much. They do very little tiny things. So we want to look at here, is this the DOS stuff? Oh no, that's the, yeah, so here's a good example of, I saw one of these ASPCA commercials the other day. I hate those commercials. And I just want to start bawling. They show you the saddest looking dogs and stuff. How could people mistreat a dog? Just want to take them out back and just punch, beat the crap out of them.
Yeah.
Yeah, kick them. Do to them what they do to.
What's funny is I think like they probably make more money from those commercials than like the starving kids in Africa commercials. You know.
I had this conversation with my wife almost right after that.
Because
I saw
a cute dog, they would make a shit ton of money.
But I saw the same thing. I saw one of those commercials. I felt significantly more sorry for the animals than the kids. Is that normal? I mean, is that just...
Well, it's the kid's fault for being born in a poor place. The dogs are just kind of like thrown into the abuses.
Well, I mean, besides the obvious. Well, but I mean, so if you watched one of those, help a needy child commercial and watched the, help the abused animal commercial, which do you feel? I mean, I know logically we should, we put humans ahead of animals, but I mean, you hope you put both of them on a pretty high pedestal, take care of, living things that can't take care of themselves. But I felt like way more sorry for the animals. Is that normal, or is that?
I think it would be what a lot of the population.
You think?
Yeah, just that it would evoke much more of an emotional response to see the abused animals.
Yeah. And they always show like the saddest ones, like the dog that's missing half its hair shaking in the back of a cage. Like, just get the credit card out, right? And you don't feel bad about doing it, right? It's not like you regret, like, oh, buyer's remorse. I just saved some puppies. Oh.
I wish I could take the back.
I mean, that could have been another Xbox. I need one in my 9th bedroom. But it was very interesting, I guess. All right, so here's our 8086 instruction set that we have linked up on the website. So this is one of our garages that has all of the Intel architecture 8086 instructions. Then we have this instruction set, which I am not positive whether I've linked up on our site yet or not. Let me copy this real quick, and just in case. Alright, so these are the 8086 instructions. Okay, so let me add web link DOS API goes to this guy, available to users, submit. Okay, good enough. So let's go back here. Alright, so here is all of the things that a very early version of DOS knows how to do in terms of what it exposes to the user. Okay? So we can read a single character in from standard input. We can write a single character out to standard input. That was for those of you who looked at the some of the Hello World examples that write Hello World, where it goes one thing at a time, it was writing one character out at a time, so it was using putting into AH the value 2. We can write a character to a printer, things like that. So
what is disk reset?
this would reset the read-write head on the hard drive back to, you think of it like a record, the very first part, segment 0. So these are all things, so, kind of going along with what Doctor said was an operating system is a resource manager. So here's stuff for dealing with files, stuff for dealing with directories, stuff for reading from a file, stuff for dealing with standard output versus standard input, things like that. And one thing you'll notice, for those of you who had the 450 class last semester, where we looked mainly at Linux as an operating system, and we said Linux was a POSIX-based operating system. And when I say something is a POSIX-based operating system, what's the If you had to say one sentence that describes all POSIX-based operating systems, what would you say? Everything's a file. Okay? POSIX-based operating systems, everything is a file, which is why when we saw the Hello World program for displaying something to the screen, so we looked at Linux, let's just go here, Linux assembly Hello World. This guy here, we moved into EAX number 4. This is the Linux API's system call for writing something out. Okay? So it's call number 4 from the Linux API. Where here we're using the DOS API right now because we're working with the EMU 8086, which is a DOS Intel architecture emulator. When we go back to looking at Cloud 9, which we have set up now, right? And we were using, MASM on Cloud 9, I think that's the one we installed. That's going to be using the Linux API. So whatever rules go to that, we'll kind of see how the API works here in a second. But with Linux, because everything is a file in Linux, it required more stuff be sent in to make writing something work. Not only did we need to tell it what we wanted to write, we also had to tell it how long it should be, and we also had to tell it what file should we write it to. Now, as a human being, when we think about a file, we tend to think of something that, like you open up a Word file, you write some stuff in it, it saves, and now it's like a file on your computer, right? But in a POSIX operating system like Linux, everything is a file. So writing out to the screen is actually stored inside of a file descriptor known as system out. The file descriptor, one of the 3 file descriptors that automatically exists in a POSIX operating system, is standard output, which would be file descriptor 1. Standard input is file descriptor 0. Standard error is file descriptor 2. After that, file descriptors are actual files or USB devices. Everything's a file, and every file has a file descriptor. Think of it as a pointer to that file associated with it. So for Linux, we needed to give our write crap to the screen more information because there isn't just a function that says write it to the monitor. The function is write something to a file in Linux. So I'm writing this guy to this file descriptor, and I also had to pass in a length. So the fact that this is a string, the string message, and this is the length of that message, what does that tell you about strings in Linux operating system? Or at least this vintage. As opposed to, so let's pause that for a second just so I can give you both sides of the coin. Let's go writing, you're not allowed to answer. So writing a string to standard out, that's effectively what we're doing, right? This right here is the DOS, the old school DOS equivalent of what we're doing here. So this is, I want to write something out to standard output. This is what I'm writing. This is how long it is. That's the Linux version of this. The DOS version of this is I want to load into AH that I want to write something to standard output, then load into DX what you want to write out. 2 things. What do I want to do? And what do I want to write? So it took 1 parameter to write something out to the screen as opposed to Linux requiring 3 parameters to write something out to the screen. So we already covered the why for one of those, right? Since DOS is not a POSIX-based operating system, everything is not by default a file in DOS. Therefore, it treats standard output as a special thing. So it has an actual API call for specifically writing things to standard out. And it also has a special API call for writing things to normal files. Because files in standard out are not the same kind of animal in DOS. They are the same kind of animal in POSIX, a POSIX operating system, like Linux. Make sense? Okay, so that's why the DOS version of write crap to the screen doesn't require us to take in where I'm writing it to, because it's presumed that you're calling this function because you want to write it to the screen. So that's why we don't need that parameter on the DOS side. But DOS also does not need that parameter, how long the string is. Why is that? Go ahead.
Because in that one, it's like a special API call. So when you say, this is the message I want to pass, it'll do it on its end. It'll find a link. This one, you're just because it's the files, you are saying, this is the message I want. But it's like, it's going to place that in ECX, and then the length is just going to go from the start of ECX until you're done with the length.
Okay. So
it's contiguous memory, isn't it?
yeah, oh yeah.
Yeah, okay.
Yeah, because ultimately a string is stored as an array.
Yeah.
Okay. So yeah, it's contiguous memory. And you're right, but what does that tell us about strings in Linux?
They don't know their own length.
They don't know their own length.
Yeah, they are.
We don't have a way to represent the length of a string within the string in Linux. Now, and that's by choice. And you'll see why here in a second. On the DOS side, 8086 vintage DOS, a string is always terminated by the string termination character, which is the $sign. Okay? Every string is terminated by the $sign. Now, what limitation does that put on us?
Can't just put dollars in strings.
Can't use $signs. Second we hit a $sign, you're done. That's right? We can't display $signs. Well, that's not true. We can't easily display $signs. If we needed to display a $sign, we'd have to do it through a single character write, rather than use our power tool that writes an entire string to the screen, because that string, the first place we hit a $sign, is presumed to be the end of the string. That make sense? All right, so strings have different rules associated with them in DOS. Therefore, we don't have to pass it the length. What do? Well, here's the string, which is it's going to be the base address of the string, right? We're getting kind of used to this idea of a base address. Keep writing crap until you bump into a $sign. And if you forgot to put a $sign at the end of your string, you're going to just keep walking memory until you hit the end of memory. Just spitting crap out to the screen. That's when you get all the weird symbols and stuff like that. It's like, look, this is what I found. It wasn't a $sign, so my job is to display it. Whatever was in that 8-bit register with the 8-bit chunk of memory, that's what I displayed. So I converted it to ASCII and said, whoa, here. Here's your garbage. All right, so in DOS, we put into DX $sign terminated string, but it's a pointer to that $sign terminated string. The memory offset from the beginning of the data segment. These were things we talked about last time. We were pointing out kind of one of the problems with the EMU 8086 is that because it's emulating a processor, it had to arbitrarily pick starting points from memory. So that's where we introduced the offset word, and we can do it relative to the data segment. So when we say the offset of our string, it's going to give you the offset of that variable from the beginning of the segment in which that variable was defined, which is our data segment. So what do we load into DX to make this guy work? We load into it a pointer to that string, and that pointer should be a number. The number of offsets, the number of bite-sized jumps I have to take. If I first go to DS, the base address of my data segment, and walk that many bytes, I'll be standing at the beginning of my string. That make sense? That's the value we load into DX. So it's not a direct memory address. It's the offset of where that string lives in memory from the starting point, which is the base address of the data segment. How many of you are confused? Half? Memory's scary, right? Once you actually understand it, it's not necessarily hard. It's just intimidating. Base address this, and how many bytes do we want? We don't think like that. We like power tools. We like these pictures over here. Okay. Double click on Microsoft Word and go to town. That's our world, right? But we're computer scientists in here. You know, any old worker can use Microsoft Word. Like if somebody walked up to you and they said, "Oh, I don't know how to use Microsoft Word," wouldn't you have a little trouble not laughing? I'm not saying they have to be a professional with it, but like, not know how to like type a couple things in and hit save. They don't have to know all the power tools, but so that's considered to be a trivial computing skill today, right? Using Microsoft Word. Well, we're computer scientists in here, aren't we? That's what the degree is hopefully going to say. Masters in basket weaving. We're 25 in here, right? Okay, we're good. All right, so starting to make some sense. So we have to hold ourselves to a higher level, or in this case, a lower level. Okay, get it? Okay. Because we're supposed to understand this stuff. We're the experts. We're the ones that need to know what's happening under the hood. So that we get paid the big bucks, right? That we can go blow on yachts and massage chairs and whatever else. We get paid the big bucks instead of doing something else. Equally decent stuff, right? Not everybody's cut out to be a computer scientist, but if you're a computer scientist, this is our world. Now, not all of us are going to be dealing with stuff like this day in, day out. But can you see how knowledge of what's happening in there can help you solve problems across the board in the technology industry? Because you get a little peek into what's happening under the hood, right? And even if you're not on a daily basis working with what's under the hood, having an understanding of how what's under the hood works might give you that one little inkling of, oh, I think I have an idea of what might be going on here when you get a weird behavior. Because usually it's the software, but it's the software that's interacting with the hardware. Or in this case, what is it? It's the software, that's interacting with, we could put another little sliver in here, maybe in Java, the Java API, the programming API, for the language you're using, which is then interacting with the system calls API, which is then interacting with the operating system, which is then interacting with the CPU. There's a lot of layers there for things to go wrong, right? So if you want to put this in maybe like a real life example, have you ever you needed to have a hose to fill something, and the hose wasn't quite long enough, so you decided, hey, let's duct tape a couple of hoses together?
No, not a scenario I've been in personally. Yeah.
But you can imagine that might be more difficult than it sounds. The points of weakness would be areas where duct tape is involved. And chances are those will not stay dry. Do slip and slides still exist?
Yep.
My wife tells a story when she was a kid that her mom once set up a slip and slide, and this was master logic, where they didn't have the things to hold it into the ground, so they put bricks. So a little kid in a swimsuit sliding around, crashing into bricks. Oh, amazing. All right, so when we look at the DOS API, we're going to load into DX the offset of a string. DX, the offset of a string, and what it's going to do as a return. So this is like a function call. This is a method. So load into DX a pointer relative to what's in DS right now, which is our data segment. That gets loaded for us. That happens automatically when our thing loads. the offset of where our string lives, and it's got to be a $ terminated string, because that's how DOS recognizes, this is DOS's API. That's how DOS recognizes the end of a string. Looks for a $. Okay? So we'll load into DX that offset, and we'll load into AH the value 9. And then we'll call interrupt 21, which is the DOS interrupt, saying, okay, operating system, take over. I've staged this is what I want to do inside of AH, and I've staged this is the crap that you need to do it into DX. And we'll know that it worked once we look in AL, the low half of AX, and see a 24 in there, kind of giving us the code that it worked. That make sense? Okay. Now, so if we have .data here, and inside of .data, we have our message is a data byte, hello world, something like that. And then we have our code segment, and we move into AH, a 9. We move into DX, the offset of message. Then we call int 21H. This is what we want to do. This is where you'll find it. Interrupt the operating system. Here's my, effectively, this is a char array up here in my DS. I go to emulate this guy. Just run it. Forget about it. I got to put the key in. But this would have outputted hello world to the. So I'll steal the key from the same place you guys got it from. Roll back an hour and 15 minutes and think about that conversation we had at the beginning of class. Okay. So I'll have
That's
to.
just a theory conversation.
I did see my pastor at church today. I'll have to text him on the way out of here and get
One
some.
more thing to add on to that.
Yes, I think I'm gonna need a. All right. So what I'm gonna do is I'll give you this as a starting point. It's not a whole lot, but I'll give you this as a starting point. I'm gonna give you a small assembly language program to write. That's going to have you define several strings and write several strings out to the screen. Just drilling this idea of offset and that kind of stuff. Should not be very difficult. Okay, but it's going to force you into thinking like our, thinking how our CPU works. Okay? So I'll post this on Slack right now. I'll put the assignment up on Blackboard in like 5 minutes. And I will see everybody on Tuesday.